Okay, for this video, we'll be discussing the May June 2025 paper 5-2 for probability and statistics 1. Question number 1. Rachel has 3 coins, and then the first coin is biased, and the probability of obtaining a head is 1/3. For second coin is also biased, and the probability of obtaining a head is 1/4. Then after that, the third coin is fair. There are 3 coins here, and you can see that each of the coin, right, is having different probability of obtaining the head or the tail. Then the Rachel throws 3 coins at the same time. X is the number of tails that she obtains. Draw up a probability distribution table for the X. Okay, so let's talk about the random variable X first, yeah. We need to know what are the possible value for X that we have in this case. For this whole experiment, we are throwing 3 coins. So when you throw 3 coins, it is possible that you get 0 tails, right? X means the number of tail. It is possible that you get 0 tail, which means that all the coins shows head. You can also have 1 tail. You might have 2 tails also when you throw the 3 coins. You also have 3 coins. You might have 3 tails when you throw the 3 coins, right? But your X cannot be a 4 because you only throw the 3 coins, right? So the maximum number of tails that you can get is only 3. Yeah, so the first step, always we try to figure out what is the possible value for the X first according to the definition given in the question. Then let us figure out the probability now. Since all the coins is having different probability of obtaining head or tail, so when you want to calculate the probability, you have to consider every single possible cases. So as an example, when we are talking about X is equals to 0, that means there's no tail. If there's no tail, means that you obtain all heads. Coin number 1 is the head. So when I write the first H here means that the coin number 1. Then coin number 2 also the head. Coin number 3 also the head. And when you're having head, then let us fill in the probability. For coin number 1, the probability is 1/3 to get a head. Coin number 2, it is 1/4. Coin number 3 is 1/2 because it is fair, right? And we multiply them together, you will be having 1/24. So this is the outcome for 0 tail obtained. So 0 tail obtained means that all the 3 coins must be the head. There's no other option. It must be always the head, right, for all the 3 coins. So there's only one outcome here, right? Then after that, when we are having 1 tail, if we obtain 1 tail, what are the possible cases that we have? We might have the first coin is a tail, followed by second and the third coin is the head. It can be also having that we are having second coin is a tail, but first and third is the head. And also we are having the first 2 coins are head, then the third coin is a tail. And now, all these cases show us that we are having 1 tail when we throw the 3 coins. Okay, so first coin obtaining a tail is 2/3. Second one is head is 1/4. The third one is half. Then plus, the second case here is the first one is the head 1/3. The second coin is the tail. Then the third coin is the head. Then how about the last one? So the last one will be, the first one is the tail. Second one is also, the first one is the head. Second one is also the head. Then the third one is the tail. It is still the half. Alright, so when you try to multiply them, simplify and add them together, by right, the answer that you get should be 1/4. Okay, so please take note, yeah, you can see that for the number of tail equals to 1, I have to consider all the cases where each coin is a tail. So I might have coin number 1 is the tail, coin number 2 is the tail, or coin number 3 is the tail. Okay, alright, then let's continue further. How about if I want to have 2 tail when I'm throwing the 3 coins? So if that is the case, I might have first tail, second tail, the third is a head. So you can see that there's 2 tails here, 2 tails with 1 head. Right? I can also have the second coin is a head. This is also 2 tails with 1 head. Then the third possible cases is first one is the head, the second and the third coin is the tail. Right, so let us fill in the probability. First one and the second one is a tail. So you're having 2/3 multiplied with 3/4. Then the third one is the head is half. Okay, for the second case, the first one is the tail, 2/3. The second one is the head, 1/4. Then the third one is the tail, half. Okay, then the third case is, the first one is a head, then the second one is a tail, and the last one is a tail. So same thing happen. All these are the possible cases for x equals to 2. Then you just add them and simplify them. You should be having 11 over 24. Then lastly, we want to calculate the probability for x equals to 3. And what do we have here? X equals to 3 means all the 3 coins show a tail. So you will be having tail, tail, and tail. Only one possible cases here. And then we are having 2 over 3. And then 3 over 4 with 1 over 2. Then by right, you will be getting the probability 1 over 4 as well. And after that, let us draw a table and show the probability with the respective value of the x. Okay, so the first row I want to put in the value for the x, the second row I want to put in the value for the p, the probability. I'm having 4 values for x, which is 0, 1, 2, and 3. Then just fill in the probability that we get. So after I simplify, I get 1 over 4, okay, 1 over 24 for the first case, yeah. So when x equals to 0, I'm having 1 over 24. When x equals to 1, I'm having 1 over 4. X equals to 2 is 11 over 24. Then after that, for the last one is 1 over 4 here. Okay, then if I want to double check and make sure that my answer is correct, right, what I usually do is like, I will try to add on all the probability that I get and make sure that I get something equals to 1. The total for the probability, if equals to 1, then very likely your answer should be a correct one. But if let's say, when you add up all the probability here, then your answer is not equals to 1, definitely there must be something wrong in your answer, yeah? So you have to double check again each of the probability that you get just now. Alright, so this is how we solve question number. Question number 2. There are 70% of the residents own a bicycle in a city. Then there's a random sample of 160 residents is selected. Use a suitable approximation, highlight the keyword approximation here. Okay, and then find the probability that more than 120 of these residents own a bicycle. More than 120. Right, so there are a few important keywords here. The first keyword is approximation. So that means we are going to change a distribution to the other one. In our AS syllabus for stats 1, right, there's only one type of approximation where we are changing binomial become normal. So this is a very obvious keyword for us, alright, to identify. And then after that, you need to know that this original distribution is binomial. Therefore, you want to change it become normal, right? Because of the word. How I know that it is binomial? So again, at first time, you can see that there's a bigger number of the sample, which is 160 residents. Then in the question, they are interested to find more than 120 of the residents, something happened to them. So this structure of the question also belongs to binomial. And you need to know how to identify the binomial and the distribution of the question. But of course, this question, the very first or the very obvious keyword is the approximation, right? Okay, so when you're having binomial distribution, the parameter is n and p, right? And you want to change it become normal, generally, you need to have mean and variance. So how to get the mean from binomial? You need to take n times p. How to get the variance in the normal distribution? It will be np cubed. Okay, yeah, so this is how you change it. Then if you want to know further, what is the condition that we can change binomial become normal? There are 3 conditions you need to fulfill. The first one is n must be large, n must be greater or equals to 30. Then the second one is np must be greater than 5. And the third one must be nq greater than 5. These are the 3 conditions that you can double check and see. If all these 3 are fulfilled, then basically you can change binomial become normal. And then one more thing to add on, binomial belongs to discrete random variable. Continuous belongs to, normal distribution belongs to continuous random variable. So from discrete, and if you want to change it become continuous, right, you have to apply continuity correction when you are doing the calculation. And the continuity correction belongs to the plus or minus 0.5, it depends on the question. Right, so we have roughly know what we should do when solving this question. So let's start. So first of all, I want to write out the number of residents who own a bicycle is binomial distributed. Original n is 160, then the probability is 0.70. And since the question already requested us to change it become normal, right? So let's count the mean. How to get the mean? You can take n times p. So n is 160 multiplied with the p. And by right, 160 multiplied with 0.7, you have 112. How about the variance? So the variance is N times P times Q. So 160 multiplied with 0.7 multiplied with 0.3, and you should get 33.6. And this is your mean and this is your variance, right? Then let's continue further. I want to calculate the probability x greater than 120, more than. There shouldn't be the equal sign here. Greater than but no equal sign. And now we want to apply continuity correction first. So what is the continuity correction for this one? Okay, for binomial distribution, all the probability looks in a line. It is like line chart like that. And then vertical line chart. And then we are having maybe a few number here, 119, 120, 121, 122, and also 123. When they said greater than 120, that means 120 is not included, which means I want to calculate the probability from 121 and so on and above. Okay, and continuity correction usually is the line that we adjusted, which is slightly before the whole area that I want to calculate, or the whole probability that I want to calculate, and this value will be to 120.5. Okay, so that means the continuity correction for this question is 120.5. Okay, so this is the continuity correction from binomial to normal. And now, if you are having a normal distribution now, then to calculate the probability, of course, you have to standardize it, right? Change it becomes Z. So you take 120.5, standardize it, is minus the mean. Minus the mean that you get is 112 divided by standard deviation, square root of 33.6. This is the process of standardization. Then you get the value of the Z. It should be 1.466. Okay, so again, a reminder, this particular value is 3 decimal places because our accuracy for the table is up to 3 decimal places for the Z. Then I have to find the probability. I have to take 1 minus, because the area in the table provided in MF19 basically is the smaller than area. Okay, but we are looking for greater than, right? So you have to take 1 minus the smaller area that we get. So looking for 1.466. Okay, page 10. Looking for 1.466. Yeah, this is 1.4. Where's the 6? 1.46 is this one, and also the 6 here. So please take 9279 plus 8. 9279 plus 8, you'll be getting 9287. So that means your probability in the step here will be 0.9287. Then get the answer should be 0.0713. It is already in 3 significant figure. So this will be my final answer. Okay, yeah, so this is how we solve question number 2, yeah. All the keyword here is shown, which is the approximation. Question number 3. There's a bag contain 4 blue marbles and also 12 red marbles. Then 1 marble is selected from the bag. If the marble is blue, then it is replaced in the bag. But if it's red, then it is not replaced. Then we take out the second marble selected from the bag again. Find the probability that both marbles selected are the same color. Right, so for this question, if you want, you can just use your imagination, yeah, to imagine what happened when you are taking the first and also the second marble out. But for me, if you want it to be safe or more visualized, can be visualized, then you can draw a table, the tree diagram to help you, right? And let's have a look. If let's say I want to draw a tree diagram, right, what is the outcome that I might have, yeah? So for the first one, I might get the red or blue marble. Okay, this is the first marble that I select. There are 2 outcomes here. Either I get a blue or either I get a red. So to get a blue marble, I'm having 4 out of the 16, right? 4 blue marble out of the 16. 16 means 12 plus 4 is 16. So 4 out of 16 means 1 over 4. I have quarter of blue marble, and then I'm having 3/4 of red marble. Okay, so that means you are having 25% of getting the blue, then 75% of getting the red. Okay, this is the first marble that you take. Right. If you imagine that the first marble that you take is actually a blue marble, when you get a blue marble, you replace it back. When you replace it back, then the bag still having the same amount of the blue and red marble, right? Therefore, when you want to get the second blue marble, it is still the same amount, which is 1 over 4, or the same probability 1 over 4. Then the red will be 3 over 4. But now, if let's say the first marble that you selected is a red marble, then you are not going to replace it back. It is not replaced. When you didn't replace it back, now your red marble left only 11, and your blue marble still have 4, right, in the back. So to get the second marble, which is the blue color, it will be 4 out of the total here, which is 11 plus 4 is 15. So I'm having 4 over 15 for the blue marble and 11 over 15 for the red marble. So the probability for this case is a bit special because you didn't replace back the red marble into the bag when you select it as the first one. Okay, then this is the outcome that we have. And let's have a look for the probability. For me, personally, I prefer to draw out the probability here so that I didn't do careless mistake, especially when I have the different probability here. If I try to draw it out in the tree diagram part, then at this time when I write out all the probability in detail, then it reduces the chance for me to do careless mistake, right? Okay, then now let's continue. Now they are saying that both marbles selected are the same color. So what is the probability of getting both marbles same color? You might have both color blue and also you are having both color red. So these are all the cases telling us that it is the same color. So if let's say I want to get blue and blue, this is the outcome that I have lah. Okay, so to get the blue and blue color, multiply the probability along the branch. So I'm having 1 over 4 plus multiply with 1 over 4. This is a complete one case. So we want to consider another case, which is red and red. We have to add them together. So the second case is red and red. So what is the probability of getting red and red? So within the branch, you multiply the probability together. So it will be 3 over 4 multiplied with 11 over 15. Okay, then after that, please try to use calculator and help you a little bit. By right, you'll get 49 over 80 if you didn't do any careless mistake. Okay, yeah, so this is how we get answer for the first part here. Then let's continue for the second part, part B. Right, so for part B, find the probability that the first marble is blue, given that, highlight the keyword given that. This is a keyword, tell us that we are going to calculate the conditional probability. Okay, and then usually it's like this, when they want you to find a conditional probability, they will tell you something like this, find A, given that B already happened before, given that B. So the keyword is a given that, right? So we know that event B already happened. What is the probability of A is happened? Then to write out the symbol for the conditional probability, given that means slash, there's a slash here. It's a special symbol for conditional probability. Given that B, the event that happened first, we write on the right hand side of the slash. Then A, we write on the left hand side of the slash. So it will be A slash B. That means find A given that B. And then there's a special formula for the conditional probability. When you're having A slash B, basically the formula is A intersect B divided by the probability of B. Okay, so let's apply it in the context of the question. Now they say the first marble is blue. So first is blue. Given that I put a slash. The second marble is a red. Second marble is the red. And if I want to put it into the formula form, it will be first is blue. Intersect with the second is the red divided by the probability of second is the red. Okay, right, so let's have a look how to get the probability for first is blue and second is the red. So again, you can refer back to the tree diagram that we drew just now. First blue, second red. First blue, second red means this one. This is the first blue and second red. So multiply the probability along the branch. 1 over 4 multiply with 3 over 4. Okay, so I have 1 over 4 multiply with 3 over 4. And now they said second is the red. How to get the probability of second is the red? When you're having any tree diagram, when they say second is the red, you cannot just consider the probability from the center or from the second part of the tree diagram. This is wrong. So you cannot tell me that, oh, I add 3 over 4 and also 11 over 15 together to get the second rate probability. It is not correct, right? So this is not correct, yeah? You need to know that when you are using any figure from the tree diagram, it must be always starting from the beginning. So from the beginning, if I want to have the second rate probability, this is the first case that I have. You have to always start from beginning part, okay? From the first marble. Then there's the second case where you're having second marble is a red, is this one. So they are having two cases here to form second red marble. both cases here are second-rate marble and you have to start from the beginning part, alright? Then if you put it into the calculation, the first case is 1 over 4 multiplied with 3 over 4. 1 over 4 multiplied with 3 over 4. That's the second case where your second marble is a red, which is this one. 3 over 4 multiplied with 11 over 15. So 3 over 4 multiplied with 11 over 15. Okay, then you try to simplify the calculation here by using calculator. If you didn't do any careless mistake, by right you should get this one, 15 over 59. I'll keep it in the fraction form as an exact value. But if let's say you want to change it become the decimal number also can, please make sure you keep it in 3 significant figures. Alright, yeah, so this is what you have for first question and also the part B for question number 3. Question number 4. We are having the vehicles that approaching certain road junction must go either left, right, or straight on. There are 3 options here. Over time, it is known that 30% turn left, 25% turn right, and also 45% go straight on. The driver of each vehicle choose a direction independently of all other drivers, so they are independent cases. Find the probability that the next 3 vehicles approaching this junction from Bromley all go in different directions. Okay, so the next 3 vehicles. So you have vehicle number 1, vehicle number 2, and also vehicle number 3. Okay, so they say all go in different direction, right? Let's say the first vehicle go on left, the second go on right, then the third one go straight on. For this case, if I want to calculate the probability, it should be 0.30 multiplied with 0.25 multiplied with 0.45. So that means these are the 3 vehicles that go into 3 different directions, right? But besides this one, it can be also left, then straight and right. Because if let's say the second vehicle goes straight, the third vehicle go right, it is actually a different result. Correct or not? Yeah. So we also can have right, then left, straight, right, straight, left. Then I may have straight, left, right, then straight, right, left. You have to consider all the possible cases for the 3 vehicles here. But if you want it to be safe, you don't need to list out everything one by one. Basically, you can just consider the arrangement for all the result here. You're having 3 different letters, right? So it'll be 3 factorial, which is a 6. So you try to count. Is it 6 different cases that I have here? 1, 2, 3, 4, 5, 6 cases, right? And then you can directly just take the first probability, then multiply it with 3 factorial directly. Then by right, you'll be having 81 over 400. Okay, so some students say that I want to list out one by one, and I add one by one can or not, also can, but it will be very time consuming. Okay, so the faster way is that you just try to consider all the possible cases for the vehicles to go. What's the direction that they should go, right? So you have to consider the arrangement for the 3 cases here, the 3 items here, right? Okay, then let's continue for part B. Okay, so for part B, find the probability that from the vehicle approaching this junction from Bromley today, the first vehicle go to the left is before the 9th vehicle. First vehicle go to the left is something, something, something. Okay, so for this example or for this question, you need to identify, is there any specific distribution for this kind of question or not? When we always mention about the first success cases happen up to the certain trial, right? So this kind of cases belongs to geometric distribution. So you can see from here, we are having the first vehicle to go left. So that means we are interested to find out the first success trial to go left. The success trial is the left. So the first success trial is before the 9th vehicle. So for this one, it is basically a geometric distribution with the probability P. P means that the success trial rate, which is the go left rate for our case here, right? And then before the 9th vehicle, it means that you want to find the probability for x smaller than something. Okay, but now let us have a look for the general formula first. If you're having a geometric distribution, to find x equals to r, the probability is q power r minus 1 multiplied with the p, which means that the r minus 1 times before the success trial all are failure. Then the last time is a success. So you can see that the success rate is only 1 for the last time. Okay. Another general formula that we are using very frequently is if I'm having x smaller equals to r, there's a shortcut formula where you can have 1 minus q power r. If you want to apply this formula, you have to memorize it by yourself because it is not provided in the formula booklet. That's the first thing. And second thing is you need to know that to apply this formula, you have to make sure that there's a smaller equals to. There's an equal sign here. Okay, then only you can apply this formula correctly. All right. Okay, so let's have a look for this question. We are interested to find the first vehicle to go left is before the ninth vehicle. That means for this example, I'm having x is geometric distributed with the success rate go to the left. What is the probability of getting a left one? It will be 0.3. And what am I interested is I want to know the number of trial is before the ninth vehicle. So x smaller than 9 before. So no equal sign. X smaller than 9. And then if I want to apply this shortcut formula, then I will be changing it become x smaller equals to 8 because geometric distribution is also a discrete random variable where all your value of x should be integer. And if I'm having x smaller than 9, it also means that 9 is not included, right? But I can also rewrite as x smaller equals to 8. That means 8 is included. Okay, so when you're having x smaller equals to 8, there are two ways for you to calculate the probability. The first one is you just try to add all the probability x equals to r one by one. Start from x equals to 1, x equals to 2, x equals to 3, x equals to 4 until x equals to 8. But for me, I feel that it is very troublesome, so I prefer to use a shortcut formula, which is this one. I can directly take 1 minus q power r. So the q is 0.7 because p is 0.3, right? So q is 0.7 power r is the 8 here. So just use calculator and help you a little bit. By right, for this question, you should be getting a long number, and I'll have to cut it short into 3 significant figure where it is 0.942. Correct to 3 significant figure. Okay. Sorry, where is it? Okay. So this is the answer that we have. Okay, then let's continue to third question. Part C. Find the probability that from the vehicle approaching this junction from Brimley today, the second vehicle to go left is the 7th vehicle. Alright, so we are talking about the second vehicle go left is the 7, right? Okay, so let's have a look how should we carry out the calculation for this one. Let's say I'm having 7 vehicles here. 1, 2, 3, 4, 5, 6, 7. The 7th vehicle is the left one. And this is the second left. Okay, and what does it mean? It means that for the first 6 vehicles here, okay, there's 1 left. There's a first left here. But the first left is where? It can be anywhere in the first 6 of the vehicle. Alright, and you should know that for the first 6 of vehicle here, if you have a look from the distribution, it is basically a binomial distribution. Because you're having 6 vehicles here and the probability of getting the 1 left means that you want to get y equals to 1 probability. Okay? Alright. So to calculate the whole thing here, the probability is what? First of all, let us calculate the first 6 vehicles with only 1 left first. So like what I told you, it is a binomial distribution, right? You are having 6C1. 0.3 power 1, that means there's 1 vehicle go to the left, the rest will be going to other direction besides the left. So it should be 6C1, 0.3 power 1, 0.7 power 5. This is for the first 6 vehicles here. And after that, the 7th vehicle must be the left. So I have to multiply with 0.3. Okay, and from here, what is the probability that we get? By right, we'll be getting 0. Again, it's a long value, yeah. I cut it short into 3 significant figure. It should be 0.0908. Okay, so this is how we get the question number 4. Alright, so question number 5. The time taken, T minutes by 300 students travel to Holoton College are recorded. The results are summarized as the table shown. We are having all the upper class boundary here because they are given us t smaller equals to 10, t smaller equals to 20, and so on. All this I assume that it is the upper class boundary. and we are given also the cumulative frequency. On the grid, they want us to draw a cumulative frequency graph to illustrate the information, and we are given the upper class boundary and also the cumulative frequency already, therefore we can directly plot the graph. Okay, so before that I need to create one more class for the upper class boundary with the cumulative frequency 0. Okay, so I will start from t smaller equals to 0 and the cumulative frequency is a 0 here, because our cumulative frequency graph cannot float halfway. It must be starting from 0 for the y, right? Okay, then let us try to draw the diagram. Fix the ratio first. We are having t from 0 to 90. So t from 0 to 90, I think this will be good. 0 to 90, right? So maybe this is my 0. Then this is the 20, 10, 20, 30, then 40, 50, 60, 70, 80, then 90. Okay, and my x-axis is the time in t minutes. So I try to label it first. Time in t minutes. Okay, then what happened to our vertical? Vertical axis will be the cumulative frequency. It is starting from 0 to 300. So 0 to 300, maybe this is what I want to draw. Let me draw a line first. Okay, so assume that this is a straight line. I cannot draw really nice. Okay, then maybe I can put this one as 50. Okay, so this is 50. Then 100, 150, 200, then 250 with 300 here. So just nice, right? And I will label this as the cumulative frequency. Okay, then I started to plot all the points here according to the diagram that we have, according to the table that we have. So the first point is 0, 0. So 0, 0 is this one. After that is 10 and 34. 10, then 34. 34 is almost at 35, right? 34. So you yourself plot it nicer, okay? Then after that, 20 is 86. So 20 is 86, 50, 60, 70, 80, 86 is somewhere slightly more than 85, right? So it should be somewhere here. Then after that, 142 for 30, 142. So it should be somewhere this part. Okay, then 40. So 40 is 208. Where is the 40? So 40 should be here. 40 should be here, then 208. Okay, then after that, 60, 265, 60, 40, 50, 60, 245 should be somewhere here. Then, sorry, 65, 265, wait, yeah, 265, sorry. 265 means that it will be, this is 40, right? Then 60, 265, sorry. 60, 40, 50, 60. So 60 at 265 should be this part. Then lastly, you're having 300 for 90. 60, 70, 80, 90. 90, I want to have 300. It should be this one. Okay, so you double check all your points here. After you plot all the points, then make sure that you try to join them by using a smooth curve. Alright, then you try to draw the curve smoothly. Of course, my one, I can draw very smooth. But for you yourself, please make sure that you draw it smoothly. If you are the one who always use the stylus pen to try out the graph, right? Please make sure that you try to use your pencil and draw it again before you go into the exam hall. Because there are some students, I believe that they might already forget how to draw nicely using the pencil. Okay, so please make sure you practice a bit before you go into the exam hall. Right, so you can see that, oh, I can't draw really nicely. So please make sure that you draw it as smooth as possible. Alright, yeah, so this is how your cumulative frequency graph should look like. Okay, yeah, so overview, this is something that you should show. So please make sure that you label the x and y axis clearly, then plot the point correctly, like at least. Okay, then of course also use the ratio correctly as well. Right, then let's have a look for part number B. 120 students take more than k minutes to travel to the college. Use your graph to estimate the value of the k. Okay, so if let's say we're having more than k minutes, there are 120 students. But for our cumulative frequency curve, right, we're not able to estimate something that's more than. We always able to estimate something that's less than k minutes. So if let's say we're having the more than k minutes is 120 students, before you can estimate the value of k, we have to change it become less than first. So what is how many students travel to school or to college take less than k minutes? So less than or equals to k minutes will be 180 students, right? So that means if you want to estimate the value of the k, you have to estimate from 180 students, but not the 120 students. It is because of, for our cumulative frequency curve that we draw, we always estimate the value that's smaller than. You can see that this is smaller than. Therefore, greater than k minutes, you cannot get the value for greater than k minutes one. You have to estimate by using this one, smaller than k minutes, which is 180 students. So we have to estimate the 180 students to get the value of the k. So where's the 180 students? It should be somewhere here. So in your diagram, please make sure that you show clearly the value 180. Then please draw the line. You can draw a dotted line, or if you can draw a solid line if you want. Then we try to estimate the value. Go and touch your graph that you draw, then reflect it downwards to the x-axis and see what is the value that we will get from here. Okay, so if I try to draw the line going down, and this is the value that I get. I know that the line here is a 30, right? So it is between 30 to 40. It is in the center. So by right, I should estimate that this value is a 35 minutes. Okay, and of course our answer here, you just need to write out k is equals to 35 minutes according to the diagram that I draw. Alright, so you no need to be too worried, because if your diagram is, you plot the points correctly just now, then your answer shouldn't be too far away from what is suggested in the marking scheme. Okay, but if your answer is too much different, that means there's something wrong with your graph. If not, then you are estimating from the wrong value. So remember, you shouldn't estimate from 120, but you should estimate it from 180, not 120. Okay, then to do the estimation, please make sure you show clearly the line that you draw to estimate the value in your diagram. Alright, so examiner will look for it. Okay, so this is how we solve the part B for question number 5. Then let's continue to part C. For part C, they want us to estimate the mean and also the standard deviation of the time taken to travel to college by the 300 students. Okay, so we have to calculate the mean and also the standard deviation. Right, so first of all, we need to have the class first. We need to have the frequency. After the class, we might need to have the midpoint. The midpoint will be our x later. And then after that, we're having the frequency, which is the f. Okay, so this is the value that I want to calculate now, and I want to get now from the cumulative frequency table that is provided in part A. Okay, so we need a little bit time of figuring out, yeah? I will show you a few class, how to get first few classes, then you try to complete for the rest of it. Okay, so let's say my first class is this one, right? T is smaller equals to 10. Basically, this one, it means that your value of T is from 0 to 10 minutes. Then for this one, it will be from 10 to 20 minutes. Okay, so maybe the 10 included is this one, belongs to this class, but this 10 doesn't include that. But no matter how, I just want the value only. I'm not going to look in detail whether the 10 is included in which class or whatsoever. I only want the value, yeah? Right, so for the first class, it is from 0 to 10. So if you want to write out, it should be 0 to 10. If you want to write it in a very accurate form, then it should be this one. But to me, this is not important. Okay, so for me, I just want to write out the value only. So it will be from 0 until 10. And what's the midpoint? Midpoint, you take 0 plus 10 divided by 2, and you get a 5. Then how about the frequency? So to get a frequency, you take 34 minus the previous cumulative frequency, which is a 0. So 34 minus 0, you get a 34. So the first frequency is 34. Okay, then how about the second class? So for the second class, you take the previous number for the upper class boundary, it is 10, until this class is 20. So it is from 10 to 20. So 10 to 20 is like this, 10 to 20. So how to get the midpoint? You take 10 plus 20 divided by 2, and you get 15. How to get the frequency? So to get the frequency, you take the second class cumulative frequency minus the first one. So 86 minus 34. By right, you should be having 52. So you write a 52 here. Is it clear? Alright, then I show you another one, the third class. So for the third class, for this one, by right, your class number should be from 20, not included, until 30 included. So 20 to 30. So third class is 20 to 30. What is the midpoint? So midpoint is 20 plus 30 divided by 2, and you get 25. What is the frequency here? You take this particular cumulative frequency minus the previous one. 142 minus 86. And what should you get? For this frequency, you should get 56. So please complete the rest of the classes using the process that I show you here. I didn't show you the class for the next few classes. I will just show you the midpoint. After 25, the next midpoint will be 35, then 50, and also 75. Okay, and after that, the frequency will be 66, 57, and also 35. Okay, so in short, yeah, actually the class is not important. Okay, because we actually need the midpoint, which is the x and also the frequency. But to get the midpoint, you need the class. But if you didn't list out the class, it's okay one, right? So some students, they will just skip all the steps here. They straight away show the midpoint in their calculation, which is okay, which is valid. You can get the full mark from there, right? But please make sure you show the midpoint in your calculation. Okay, so after I get a midpoint, after I get a frequency, so I can start calculating the mean. What's the formula for the mean, yeah? Do you still remember? Okay, so the mean formula is, I should write here, right? Okay, so the mean formula should be summation of fx divided by the summation of f. Summation of fx means that you take all the frequency, multiply with the midpoint. So first frequency, multiply with the first midpoint. Second frequency, multiply with the second midpoint, and so on. No enough space. Where? Can I just move it a little bit up? Okay, then after that, the last class is 35 frequency, multiply with the midpoint 75. Then divided by the total frequency. Total frequency means that the total cumulative frequency that you have just now, what's the last cumulative frequency that we have? It is 300, right? So you can directly write 300 if you want to save time. And simplify all the values here, you will be getting this 10135 over 300. Then simplify further, you have 2027 over 60. For me personally, I will keep it in fraction form. If you don't want, you can correct it to 3 significant figure, where it will be 33.8. Alright, then after that, they also want us to calculate the standard deviation. To get the standard deviation, let's recall about the formula one more time. For the standard deviation formula, it should be the square root of, if variance then has no square root, if standard deviation then you will have a square root here. It should be summation of fx squared divided by the summation of f minus the mean square. This is a formula for the standard deviation. And let's apply it here in our calculation. Okay, summation of fx squared. That means you have to square the x multiply with the frequency. So you take frequency, multiply with the x squared. X squared means 5 squared. X is a 5, right? Midpoint, then square. Okay, then the same thing happen for the rest of the class. Fx squared okay, divided by the summation of f, which is also 300. Wait, 300. Okay, then minus the mean square. Okay, what's the mean that you calculate just now? Please make sure that you use the full value here. Don't use the shortcut answer here because this is not the original mean. So that's the reason why I always keep the fraction form. It is because of if I want to apply in the next part, then usually I have to put it back into the original form, which is a fraction form. So 2027 over 60, and then I have to square it. Please don't use 33.8, yeah, because 33.8 is an answer that has been cut short. Okay, all right, then double check and see. Do you get this or not? By right, you should be getting this. 46775 over 300, then minus this square, mean square. Okay, then don't forget to take the square root. By right, you get a list of long answer. Then if I cut it short into 3 significant figures, it should be 20.4. Okay, so you double check and see whether you're able to get this answer or not. Alright, this is how we solve question number 5. Question number 6. Find the number of different ways in which the 10 letters in the word, this one, oh, it's a long word, amalgamate, can be arranged so that there's M at the beginning, M at the end, and also no A's are together. Highlight the keyword arrange. This word tells you it is about the permutation, which is the arrangement. So for your permutation, right, usually your steps will involve a lot of NPR and also N factorial for permutation most of the time, okay? But it is not 100%, yeah, but most of the time this is what we need to include in our calculation. Let's figure out how many identical letters that we have first when you want to arrange them. For this word, I'm having 4A, then 2M, 1L, 1G, 1T, and also 1E. So total there are 10 letters here. And they are already fixed some restriction for us, M at the beginning and also M at the end. Which means that the M are fixed. I'm not going to touch the M anymore, but I want to arrange the 8 letters in between. 1, 2, 3, 4, 5, 6, 7, 8. The 8 letters between the two M. Both M are fixed there. We don't touch it anymore and we don't arrange it anymore. We only want to consider the arrangement for the 8 letters inside. For the 8 letters inside, no M, right? No more M. So for the 8 letters inside, what do we have here? 4A, 1L, 1G, 1T, 1E. When we are arranging 8 items, so, I cannot arrange the 8 items directly because there's another restriction here. Sorry for that. No A's are together. Okay, so when I'm having no A's are together, that means all the A must be separated. When some items must be separated, I will arrange them lastly and last, okay? So first, let us arrange the 4 letters here first. I try to arrange the 4 letters here, 4 items, so it should be 4 factorial. For 1L, 1G, 1T, 1E. There's no identical letter here, right? L, G, T, E. So it will be directly 4 factorial only. After that, I want to place the A between them so that there are no A together. When I want to place A between the 4 letters here, how many space available for the 4A? 1, 2, 3, 4, and also 5. 5 space available for 4A. If you want to write it out for this one, it will be 5P4. 5 space available to arrange in the 4A, 5P4. But because the 4A are identical letter, therefore you have to divide it by 4 factorial. Okay, and after that, when you try to calculate the answer, it should be 120. You can make a small note for yourself if you are not so sure how the values come from. Okay, so for the 4 factorial here, it comes from LGTE. I arranged all the 4 letters here first because in the restriction, they did mention that A must be separated. Usually for the separated case, I will arrange them lastly and last. Therefore, you can see I arranged the 4 letters first, followed by the A that must be separated. Okay, yeah, so that's what we have for part A. Then let's continue to part B. Find the number of different ways in which the 10 letters in the word amalgamate can be arranged again, highlight the keyword arrange, with exactly 3 letters between the two M's. Right, so if I want to have 3 letters between the two M's, again, there are many ways for us to solve it. Let me write it out first. 3 letters between two M means that I'm having M, then 1, 2, 3, then the other M. Then after that, 1, 2, 3, 4, 5. 5 letters here already, right? Then 6, 7, 8, 9, 10. Okay, there are many ways for us to do the calculation for this one. And then for me, if I want to make sure that every single letter in between, right, all these letters here can be arranged freely, I just try to consider what are the possible position for the M first. So this is the first position that I have. The second position is I can have this one. I have 1 letter in front, followed by M, 3 other letters, then followed by M again. Okay, so if I try to list out everything one by one, I try to arrange all the possible position for the M with 3 letters between the two M's. So from here you can see that you're having 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 6 possible position, right? So all this means 6. Okay, but of course some students will say that, oh, why don't you consider like, or you group the M, 3 letter and the M together as one unit, then the other thing as one. Also can, but because for me my habit is I prefer to keep all the letters arranged freely, so I don't want to group like M and the 3 letter in between as a one unit. I want to arrange all the letters freely. So what I do is I just try to consider the position of the M first. Okay, then after that only I can arrange all the letters freely. Alright, so there are many possible ways, and it actually depends on the habit of someone who solved the question. So if your method doesn't follow what I show here, it didn't mean that your method is not good or your method is wrong. Alright, as long as you can get an answer and you know how to explain from what you are applying, then it is a good method. Right, so maybe sometimes when you question, or maybe when you ask, why don't you use this method in the comment, I'm so sorry that I cannot answer all your question one by one, because maybe when you elaborate your method, I can't really get it, or maybe I don't really think in the way that you solve. Alright, yeah, so if you need more explanation, you can figure out some other example, or maybe some other videos or explanation, or maybe from some other friends, and see whether they can give you a better input or not. Right, yeah, so there are many possible ways. Okay, so for me, the habit is I prefer to arrange the items one by one. I mean, I want to arrange the item freely instead of I group them as one unit. Okay, unless there are some question or restriction saying that, oh, I want to group all this as one, cannot be separated, then only I will group them as one unit. If not, I prefer to arrange them freely. Alright, yeah, so the 6 here basically means the 6 possible position for the M. And after that, I'm having all, for every single cases here, right, I have 8 space blank, right? So for the 8 letters here, I want to arrange them. So how can I arrange the 8 letters? So I'm having 8 factorial. But from the 8 letters, the 8 letters means this one, 4A and also these 4 letters. So I arrange them freely among the M, among all the space here. Okay, so 8 factorial. But from the 8 letters here, there are 4 identical A. So I have to divide by 4 factorial. And from here, you'll get the answer 10080. Right, yeah, so this is how we get the answer for part B. Okay, then of course, I did try some other example also, some other method for this part also. And to me, I think this is the shortest, and I feel that this is more convenient for me. Which means that I just try to consider the position for the M first, then I arrange all the 8 other letters freely. Okay, alright, so let's continue further to part C. Okay, so for part C, 5 letters are selected, highlight the keyword selected. This actually gives you a keyword or idea saying that we are going to select them and involve combination. And your combination question are usually the steps involved will be NCR, alright? Okay, so now they say find the number of different selection where the 5 letters include at least one M and also at least 2A. Okay, so I'm having a few restrictions here for the selection. Okay, so first of all, I try to arrange them into different part first. I'm having either the M, I'm having the A, I'm having the other letters. If I want to select 5 letters, right, then they say at least 1 M, then 2A. This is the minimum. Minimum 1 M, minimum 2A. So for this case, we can have 2 others. You can also have 1 M, 3A, 1 others. Then add together is a 5, right? 1 plus 2 plus 2 is a 5. 5 letters. Okay? Or 1 M, 3A, and 1 other letters. 1 plus 3 plus 1 is also a 5. Okay? So can I have 1, 4, 1 M, 4A, then 0 others. 0 letters. Okay? Then what else? Can I have 1 M with 5A? Cannot, right? Because I don't have 5A also. And then if you put it in this way, basically already more than 5 letters that you want to select. So you cannot have 1 M and 5 A's anymore. Okay, then let's consider increase 1 letter for M. Can I have 2 M and 2A? Can. So 2 M, 2A, then 1 other letter. You can also have 2 M, 3A, then 0 other letter. Can you have 2 M, 4A? You have 4A, but you cannot choose 2M and 4A because if you choose 2M, 4A, it already has 6 letters in total, which is not what we want. Okay, so after you list all the possible cases, this is what we have. And then to calculate the number of selection, highlight the keyword number of selection. That means no matter how many M do you have, when you select it, it is still referred as 1 M only because the result shows only 1. Okay, then no matter how many letters do you have in the A, 2 letters you choose, A is still the same A, right? The result still show you A, only 2A. Therefore, for this case, to select the combination, you need to consider the others case. So you're having 4 other letters, you want to choose 2 of them. Okay, then for this one, it will be 1M, 2A. No need to bother about them, but you have to choose choose 1 letter from all others letters. So 4C1. Then this one is 4C0. This one is 4C1 again. This one is 4C0 again. So you can see that all our combination here, we focus on the other letters because there are 4 other letters and you want to choose 2 of them, 1 of them, and so on. All the M and A, because they are identical, so you no need to consider about the selection. Okay? Alright, then when you try to get the answer for every single case here, it should be 6, 4, 1, 4, 1. And the total selection will be, you just add them together, by right you are having 16. Okay, so this is the number of different selection when you want to select 5 letters from the 10 letters here. This is what we have. So focus on number of different selection. Okay, then for recent years, there are a lot of students start asking, they'll ask why sometimes the identical letter I also need to choose. Okay, so there's a difference when they ask you to calculate the number of different selection and also the probability of the selection. Okay, if they're asking for the probability of the selection, then all the identical letter, you also have to consider the selection, because of when you're having more A happens, that means they are having higher chance to get the letter A, and therefore it will affect your final answer for the probability. Probability is talking about chance, right? So more A means more chance. Okay, so when they're asking for the probability of the selection, then you have to consider all the identical letter. So I just show you the example, yeah. If they're asking for probability, right? Okay, in purple color, yeah. For our question, it is the red color. This is our question. But now if I modify our question into the probability, then for probability, you also need to list out all the possible cases first. For the first case, 1m means that you're having 2c1 multiply with A. You're having 4 letter A, right? So 4ca. Then multiply with 4c2. Then multiply with others. Others is 4c2. Then you get an answer for this one. After that, 1m. For the second case, also 2c1. Then 4c3. Then 4c1. Okay, then if for the probability, after you calculate the cases for all the 6 possible outcome here, you need to get the total without restriction. So the total without restriction, oh sorry, I shouldn't put it here. It should be something like this. Total without restriction. Oh, since I already tried out now, how about I try to calculate the probability for you so that you know the proper difference, yeah? Okay, this is number of combination. Then this one is to calculate the probability. So I try to complete the calculation. So 2c1 multiply with 4c2 multiply with 4c2. I'm having 72 for this one. Okay, then 2c1 multiply with 4c3 multiply with 4c1. I'm having 32. Okay, then the third case is 2c1 multiply with 4c4 multiply with 4c0. Okay, so I'm having 2c1 is a 2, right? Okay, then the next one is 2c2 multiply with 4c2 multiply with 4c1. So 24. Okay, then 2c2 multiply with 4c3 multiply with 4c0. Okay, then you get a 4 for this case. And then you get the total cases first. So the total cases will be 72 plus 32 plus 2 plus 24 plus 4. Okay, so total them out, 72 plus 32 plus 2 plus 24 plus 4. By right, you'll be having 134. But when they're asking for the probability, you need to calculate the total without restriction also, which is equals to 10 letter, you want to choose 5 of them. Okay, so 10 letter, when you want to choose 5 of them, you will get 252. And now, if to calculate the probability, you have to take the total cases with restriction divided by the total without restriction. So 10 letters, you want to choose 5 of them, right? So 134 divided by 252. By right, you'll be having 0.532, correct to 3 significant figure. So I hope that you can see the difference when they are asking you to calculate the number of permutation, then this is what we have. And you can see that we didn't include the selection for the identical letter. But if they're asking for the probability that involve the selection, then for all the identical letter, you have to include it in your calculation for the number of cases, because of the more letters appear, identical letters appear, it will affect the chance of it being selected. Therefore, when you want to calculate the probability, you have to include all the identical letter as well. So that's the difference between number of different selection and also the probability of different selection. Okay, so I hope that you can see the difference between this one, right, and don't feel confusing anymore, because for recent years, there are a lot of students actually feeling confusing, like why sometimes they didn't include the identical one, but why sometimes they include the identical. So this is the difference. All right, I hope that this part will help to clarify some of your doubt, right? Okay, so this is how we solve question number 6. Okay, so we are now at the last question for this paper. Kestrels. I don't know what is that, but they are birds, birds whose adult wingspans are normally distributed, highlight the keyword normally distributed, with the mean and also the standard deviation given. There's a random sample 120 birds is selected. How many of these 120 birds should you expect to have the wingspan between this height, this length? Alright, so it is normally distributed. So we're having x normally distributed with 74.8 and also 3.2 squared for the variance. First of all, let's figure out what is the probability of the wingspan between 72.4 to 76.3 first. Okay, this is a normal distribution. So to calculate the probability, of course, we have to standardize it first, become the z, right? How to standardize it become the z? You have to take the value of the x minus the mean given divided by standard deviation, which is 3.2. Same thing happen for this side also. Okay, and then after that, try to use calculator and help you a little bit. By right, your z is negative 0.75 to the z is 0.469. Again, if you are having a long value for the z, please make sure that you keep it up to 3 decimal places, yeah, because our accuracy for the table given is 3 decimal places of the z. Right, then after that, to calculate this probability, it is the z bounded by 2 value, right? There are many ways for you to calculate the probability here. For me, I always use the same method where if I try to figure out the diagram, right? This is negative 0.75 and this is the value of 0.469. I'm interested to find out the area between these two values. This is the area that I'm interested. And usually when I want to find out the area here, what I do is like, I always take this particular area. Can you see the red color area here that I put like this? So this red color area, if I want to write out in a symbol form, it should be z smaller than 0.469. But because my final answer, I'm only interested for the shaded area, right? So I have to take the red color area minus this blue color area that I'm drawing now. Can you see the blue color area that I'm drawing now? So that means I have to minus the blue color area, which is the probability of z smaller than negative 0.75. Okay, so this is how the formula comes from. Okay, because I know that this particular step shows the area that I want to find. And to get the shaded area in black color here, I take the red color area minus the blue color area. And this is what we get. Alright, after that, I can start finding out the area from the table. Z smaller than 0.469. So go to the table looking for 0.46 is this one. Then 9 is the last value here, right? So you take 6772 plus 32. Plus 32, so you see you will get 6804. Okay? And go back to our calculation. This area is 0.6804. Minus, copy the minus, looking for z smaller than negative 0.75. So go to the table. There's no negative 0.75, but I look for 0.75 first. 0.75 is this one, 7734. Okay? The 7734 is z smaller than positive 0.75. So smaller than negative 7.05 negative 1 is actually 1 minus 0.7734. Okay, so if you want to know why is it 1 minus, it is because of this is negative 0.75, right? I want to find this area. Then this area is same as this one. Okay, but from the table, the value that I get is smaller than 0.75, the whole area at the bottom, this one. So that's the reason I need to take 1 minus the area that I get from the table, then only I will get this part. Okay, but all these are quite basic. If you are still feeling very confusing, please go back and do some revision again for this part, yeah? Right. Then after you minus everything and so on, then just simplify your answer. By right, you'll be getting 0.4538. This is a probability. Okay, but if you read the question one more time, they're asking for how many of the birds are having this wingspan. So we only get the probability. So to get the number of the birds, you have to take the probability multiply with 120. So you can just write out the number of kestrels. Maybe I have to go and search what is it. Okay, so the number of kestrel will be 120 multiplied with the probability. Okay, then definitely you won't get a nice answer, right? You should be getting a decimal number. For me, I get this 54.456, but the number of birds should be in integer. So please make sure that you keep it into the integer, either 54 or either 55. Just write out one integer answer will do. Okay, so for marking scheme, they will accept both answer round up or round down, but you just need to write out one answer, yeah? So for me, I will just write it down as 54 for this case. Okay, so this is what I have for 7A. Then let's continue to 7B. 7B is here. Okay, then now they are saying that, oh, okay, I'm still having normally distributed for the mass. And then the mean is mu kilogram, standard deviation is sigma kilogram. Note that 20% of the adults has mass greater than 0.202. 28% has this one. Find the mean and also the standard deviation. Alright, so to find the mean and standard deviation, we need to form two equations and solve them simultaneously. Let's have a look here. I'm having the first information, 20% is the probability. 20% has the mass greater than this amount. Let's say now the x is the mass, right? If I try convert it into a symbol form, the probability of the mass more than 0.202 kilogram is equals to 20%, so equals to 0.20. This is the first information that I get from this particular sentence. And since I know that it is normally distributed, therefore I have to change the x become z. So to change it, I will have minus the mean divided by standard deviation, which I don't know the value, but I know that it is equals to 0.20. And from here, if I try to figure out the diagram, how can I show this in the diagram? Okay, z greater than a value equals to 0.2. 0.2 is a small area. So by right, this is the 0.2. Then the complement area will be 0.80. Okay, then this particular value here will be the z for this one. And I want to find out this particular value of the z. Okay, then I should find out the table in the reverse way. So to find the table in the reverse way, right, I cannot find the 0.2 because from the reverse, the area, the area given is this part. Z is outside. Okay, my area here is 0.2. If you look for the area, there's no 0.2 inside because the smallest value is 0.5 for the area. Therefore, I cannot use the 0.2, but I have to use the complement area, which is the 0.8. Looking for 0.8 here. Okay, so let's us figure out, what do we have for 0.8? Look for a value closest to 0.8 but smaller than it. So I'm looking for this one, 0.7995. I need to add a 5 at the last digit so that it becomes 0.8. So read the value out. Read out here, it will be 0.842, which means that your value of z here will be 0.842. Then now you decide, is this value a positive value or negative value? So according to the diagram that you draw just now, the center is here. The center here is a 0. And this line is after the 0, which means that it is a positive value. Therefore, it is a positive 0.842. And this value and what we have here is the same. Therefore, we compare them. 0.202 minus the mu divided by standard deviation, and you get 0.842. So that means z greater than 0.842 is equal to 0.2. So 0.842 is this one also, right? Therefore, I compare them directly. Okay, from here, I will get the very first equation. Okay, so with one equation, it is not enough for me to solve it. Then let's form the second equation. For the second equation, now they say 28% has mass less than 0.185 kilogram, less than. Okay, so for the second equation I can form here will be the probability of mass less than 0.185 is equals to 0.2828%. Okay, then again, it is still normally distributed, right? Of course, we have to standardize it. So to standardize it, it is minus the mean divided by the standard deviation, and it is equals to 0.28. Let us visualize it using a diagram to help us. 0.28 is a small area also, and z is smaller than. So smaller means that when you draw the diagram, it should be somewhere here. Then this is 0.28. The complement area will be 0.72, and this is the value of the z that we want to find. Same thing happened like just now. We are not able to find out the value of z using 0.28 because this is a small area. I have to use the complement area 0.72. Go back to the table again, looking for the area 0.72. The closest value to 0.72 is this one. You have to add a 10 at the last digit, so last two digits, so that it becomes 0.72. Read out the value here, you will see that it is 0.583. Okay, so when I write it out here, it will be 0.583. But if you try to look at this particular diagram that we draw just now, right, your 0 is in the center, and this z value, the z line, is before the 0, which means that it should be a negative value. So this z is actually a negative 0.583. Okay, then from here, you know that z smaller than negative 0.583 is 0.28. Therefore, I compare it by using the value that I get. So 0.185 minus mu divided by the standard deviation is equals to negative 0.583. And from here, you will basically get the second equation. Okay, then to get the value for mu and also the sigma, I think you should know, right? You have to solve them simultaneously. Okay, so can you please solve them simultaneously on your own? Okay, maybe I just roughly show you. I will let 1 equals to 2. Okay, so when I try to solve them, I will be having this at 0.202 minus 842 sigma. Okay, then 1.425 sigma is equals to 0.017, and the sigma that I get basically is 17 over 1425. Again, I will keep it in a fraction form. Okay, then sometimes our students prefer to change it become the decimal number, then please make sure you keep it into 3 significant figure. Okay, for me personally, I will keep it in the fraction form. Do you know why? Because later I still need to use this fraction to calculate the mu. Okay, after you get a sigma, then of course you can continue to calculate the mu. So how to get a mu? You can use any equation that you have just now, either equation number 1 or equation number 2. And you can see that when I try to get the mu, I will use the original fraction for the sigma. I will not use the simplified answer. Okay, then your mu, you also will get a long value, but you can cut it short into 3 significant figures as well. And the answer should be 0.192. Okay, so this is what we have for part B. And let's continue to the last part for part C. I'm having 10 adult birds are selected at random. Find the probability that fewer than 3 something 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 something. 10 birds, fewer than 3 something 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 happen to them. This kind of structure belongs to binomial distribution. I hope that you know how to identify it, yeah? Alright, so I'm having 10 birds, then fewer than 3, greater than 0.202. What is the probability of greater than 0.202? I think it's here, right? Yeah, greater than 0.202 is 20%. That means in my calculation here, the P here will be 20%, which is 0.20. We are interested for the probability of Y smaller than 3. Y is less than 3. So how to calculate the probability? You should start from Y equals to 0, Y equals to 2, Y equals to 0, Y equals to 1, and also Y equals to 2. For Y equals to 0, it is 10C0, 0.2 power 0, 0.8 power 10. Do you still remember the general formula? This is the N, this is the P, right? Okay, when X or Y is binomial distributed, the general formula for X equals to R, it will be NCR, P power R, then Q power N minus R. Okay, so this first phrase here is the Y equals to 0. After that, Y equals to 1, that means R equals to 1. So you're having 10C1, 0.2 power 1, 0.8 power 9. Then 10C2, 0.2 power 2, 0.8 power 8. Should I continue with 10C3? You can see from here, I'm only interested for Y smaller than 3, not included the 3, right? So you should stop at Y equals to 2. Then you just try to press calculator and help you. Again, you will get a very long answer. Then please cut it short into 3 significant figures for this case. By right, you will be getting this answer, which is 0.678. Alright, yeah, so this is what you have for question number 7. And this is the end of the video. Thank you very much for watching this video.